Welcome to lesson 4B. And in this next preview assignment in the next class, you will need to be able to calculate, and it's doing that again. You'll need to be able to calculate chance and interpret standard probability notation. So we're going to start by talking about chance. As normal, I need you to go ahead and hit pause and work on question 1A, B, and C all the way through D by yourself. But before you pause, I need you to get a container that you cannot see in, like a brown paper bag, something, a gift bag, and I need you to find make 5 red pieces of paper and 3 yellow pieces of paper with 2 blue pieces of paper. And I'm going to end up doing this just visually with dots on the screen. And that's okay, but I really think it would be very beneficial for your learning to actually touch the 5 red cotton balls or 5 red craft balls, 3 yellow, whatever you can come up with this combination, and then answer questions, or question 1, parts A, B, C, and D. So to answer the questions using the materials provided by your instructor, well, I just asked you to make them. How many objects are in your container? If there are 5 red, 3 yellow, and 2 blue, we have 10 whatever the objects are that you gathered. What color objects are in the container? We have 5 red somethings, 3 yellow somethings, and 2 blue somethings. Can you guarantee drawing a blue object out of the bag if you do not look inside while you're picking it? Can you guarantee this? And the answer is no, as long as you didn't make 5 red pieces of paper and 3 yellow balls, something that you could tangibly feel the difference. If they're all pieces of paper, they're all the same size, you cannot guarantee that when you reach your hand in the bag that you will always pull out a blue object. It's not likely. The chance is you won't do it. The odds are you won't do it. If you have no way to distinguish the colors, you cannot guarantee that you will draw blue every time. I'm just going to look on my paper for D, and it says what color object is most likely to be drawn. So you're looking at D, and D says what color is most likely to be drawn. And when you look over here at our numbers, which numbers represented the most in the bag, well, then that means there it is, likely. That means red, because there are more red whatever objects in the bag than any other. So it's still not a guarantee, but it's more likely that you will draw red than yellow or blue. And then it says, oh, that was finishing the sentence if you're not looking. And why? Well, there are more of them in the bag than the yellow or blue colors. Reading more after our question number 1, a way to represent probability or chance that an event will happen is to write it as a fraction. Put this in your glossary, put this in your flashcards, if you're doing sticky notes, however you're keeping up with your words. Make sure that you note the numerator is going to be the total number of desired item. Like I want to reach in the bag and draw out blue. Well, how many blues are even in the bag? Out of the total number of all the items in the container. Earlier, I'm getting ahead of myself here, but I'll go ahead and say, earlier in our bag, we had 2 blue. We had 2, if we were talking about drawing a blue out of 10, we can leave it as that fraction, or we can reduce it. Uh-oh, these go away. And we get 1/5, 1 out of 5. For every 5 times you try to draw a blue object, you'll get it 1 of those 5 times. Those are the odds, the probability, the chance, the likelihood. The fraction can either be reported in an individual original form or reduced, and you would describe the fraction by saying there is a 2 in 10 chance of drawing a blue object based on the example I just did. Question number 2, before you keep listening to this video, hit pause, you write down an answer for 2, and then come back. So in question number 2, it says, what is the chance, written as a fraction, that out of the bag you created, red will be drawn? Remember in our description, the total number of the desired item will go in the numerator. Well, in our bag, how many red objects are in our bag? There are 5. So the total amount of objects that we are trying to find or get, we have 5. Denominator will be all of the items in the bag. There are 10. We can leave it as is or reduce it to 1/2. Either way we go, the contextualized sentence needs to say something like 5 out of every 10 times we draw an object out of our bucket, bag, we will get a red object, whatever your objects are. You can also say something like 1 out of every 2 times that we draw an object from our bag, we will get, I hate to say we will, there's a chance that we will get a red object. Later, we can even talk about these as percentages. A 50% chance that we're going to draw a red, whatever's in your bag. In the lessons in 1332, we're going to do several things looking at risk and chance. And one of the things that we need to practice is the note I've got here, before proceeding. Before proceeding, lost my marker. Marker, color. Before proceeding, take the red objects out of your container and then answer the following questions. So, if we take the red out, we still have 3 yellow in our bag or whatever we have, and we still have 2 blue inside our container. How many objects are left in the container? Well, we can count them, we can look at them, we can start all over, but we have 5 objects, whatever you have. We can count them, we can subtract them. If we had 10 to begin with and we took 5 red out, that means we still have 5 in our bag. What is the chance, written as a fraction, that we are now going to draw a red from the container? Well, remember we put how many, or as the fraction says, the total number of desired items in the container. How many red items are in the container? None. How many items are in the container? 5. I can leave this as 0 out of 5. In other words, we are never going to draw a red object out of the bag that doesn't even have red objects in it. We can reduce that down and just say 0 chance or 0% chance. It is asking for a fraction, so I'll stick with this one. We are not going to draw a red item out of our bag. Contextualized sentence. It is impossible to draw red out of our bag as we currently have it. There is a 0 chance out of every 5 tries that we will get a red object out of our bag. Question 5, oh, and by the way, if you didn't already stop and answer questions 3 through 7, go ahead and stop. Get some answers down for these. Make a very great effort to do that and then come back. Question 5 says, is there an equally likely chance? So if I stick my hand in that bag, do I have the same chance I'll grab a yellow or a blue, and it's an equally likely chance, as long as I'm not looking? Why or why not? Well, I have to go back up here and note that I have 3 yellow whatevers in the bag and 2 blues in the bag. So it's not an equally likely chance. There's a greater chance I'm going to draw yellow. So why or why not? There are more yellow objects in the bag. There is a greater chance that I will draw a yellow object instead of a blue one. So question 6, it's the same thing. So which color is most likely to be drawn if you do not look while picking? Yellow. I've got a 3 out of 5 chance to grab yellow versus 2 out of 5. And we could even look at these as decimals. We are only looking at them as fractions right now. But 3 out of 5 would be 60%. 2 out of 5 would be 40%. What color is most likely to be drawn? Yellow. There are more yellow objects in the bag. What is the chance? Wow, I'm ahead of myself, sorry. What is the chance on number 7, written as a fraction, that the color you selected in the previous question, we picked yellow? What is the chance that it's going to be drawn, and write a contextualized sentence? So the chance, 3 out of 5, that we will draw yellow. So there's your sentence. Out of every 3 times, out of every 5 times we draw an object out of this bag, the chance of grabbing a yellow, we have 3 is a 3. That's not written very well. But 3 out of the 5 times that we draw an object out of the bag, it will very likely be yellow. Let's finish up this lesson talking about some probability symbols. Again, a reminder that in the back of your in-class notebook, you have resources, and one is titled Probability, Chance, Likelihood, and Odds. I encourage you that when you hit pause before doing question 8, you go ahead and go glance through, look at, print, highlight, underline information on that resource. Go ahead and hit pause, and then come back and we'll do question 8 together. So question 8 is talking about probability, and then it's walking us through in part A, let's let X represent living in Wichita Falls. P of X, what is that going to mean? It means it's the probability of living in Wichita Falls. Okay, that's what that means. We're going to need to know how to write items as the probability of, and then describe what the of is that we're talking about. So playing around with it a little bit more. If Y represents being named Connie, what does P of Y mean? Well, it means the probability of being named, how about this nice writing, Connie. So some terminology, P of Y in this particular case would mean what's the probability of being named Connie? Let's put all of that together. Using the information, the terminology, the phrasing, if somebody puts this at us, whoops, what does this one mean? Well, it's going to mean what is the probability of, let's see, X was living in Wichita Falls. So what would be the probability of living in Wichita Falls and be, sorry y'all, I'm writing all over the place. I'm trying to turn my tablet. It's not working with me here, or I'm not working with it. And being named Connie. So a little bit of terminology, and I want to go ahead and share 2 more symbols that you will see inside your lessons. And these 2 can be confusing, so let's just go ahead and look at them. I'm going to leave all of this stuff up here and try to slide this in right here. I'm going to try to slide in P of X, a bar, and a Y. We're going to end up talking about patients with cancer. I'm going to talk about patients who have died from cancer. And it'll be a sensitive topic that we'll be talking about numbers with no disrespect for people with cancer. But looking at this probability of this thing here, we're going to be pronouncing it as the probability that X will happen given that Y has already happened. So to write this out, it would be, what is the probability, what was X, that you live or someone lives in Wichita Falls given that their name is Connie. So the big piece I want you to hear is when we're talking about this back end, we're asking the probability of this happen given that this has already happened. In other words, what's the probability that somebody's going to be living in Wichita Falls given that their name is already Connie? So it doesn't work out as well here, but I want to introduce you that we're going to be talking about people who have died from cancer, given that they already had cancer. And so we can turn this around, and I'd like to go ahead and do that just to hear these words one more time. If we write it like this one's going to be, what's the probability of, and what was Y again? Of being named Connie, sorry, I'm writing this sloppy, just trying to get through the words, that we're going to be named Connie, given that you live in Wichita Falls. Sorry about throwing that T in there every time. Wichita Falls. Again, stressing, we'll be talking about the probability of an event given that this other event has already happened. What's the probability of being named Connie? And you already, of those who already live in Wichita Falls. Or over here, what's the probability of living in Wichita Falls given that your name is Connie? Again, we'll be talking about cancer-related issues. This concludes our lesson 4B. Look at your calendar, see if you have any more lessons to do before our deadline this week.